Welcome back. In a previous video, we saw that the covariance of two random variables is related to the strength of their linear relationship. In this section, we're going to see 7.6.3, the correlation, which comes about because the covariance is not an ideal measure of the strength of the linear relationship, however. It is very sensitive to scaling. So for example, if x and y represent money and if they have positive covariance, then the covariance of x and y is much larger when x and y are measured in cents than when they would be measured in dollars. And that is even though the relationship between these variables, right, the units that they have changes nothing. The relationship between them is exactly the same. So clearly that is not desirable. You want something to measure the linear relationship independent of the units that the variables have. And that something is going to be the correlation. So definition 7.6.3, the correlation of two random variables x and y is or correlation of x and y, which is also written rho of xy. That's the same RHO, that's the same Greek letter that we used for density. And it is the covariance of x and y divided by the standard deviation of x and the standard deviation of y. So where sigma sub x is the standard deviation of x and sigma sub y is the standard deviation of y. And we remember that the standard deviation is just the square root of the variance. So a little remark, when it's clear that which the two variables are that are being referred to, very often we'll just write rho instead of rho of xy. So for example, like here, proposition 7.6.2, the properties of correlation. 1, it can be shown that rho is always between -1 and 1. Rho is equal to these values, plus or minus 1, if and only if there is a perfect linear relationship between the two variables. Rho is greater than 0 if the trend between the variables has a positive slope, so that's just like the covariance, and rho is less than 0 if the trend between the variables has a negative slope, so also like the covariance. So linear regression, there's a whole study in statistics about linear regression, which is using a sample statistic R to attempt to predict the value of rho for variables, two variables like x and y, and to give the line of best fit for the sample data. That will not be our focus here. We'll calculate the covariance and the correlation in consequence of it, but we are mostly going to be working with the covariance and the properties thereof.